Welcome to Mechanical Engineer Gate Tutorials, and in this video lecture I am going to explain about uh, how to find the total extension of a bar with varying cross-sectional areas. So that means here how to find the change in length of entire bar which is having the different cross-sectional areas. So that I am going to explain here. So first, I would like to take one example as a bar with a varying cross-sectional area is subjected to an axial pull here. So that means it is applied with a tensile force. So for example, I am taking one bar that is having three different cross-sectional areas. That is only bar of varying cross-sectional area. And here I'm considering first initially the dimensional values as d1 and d2 and d3 for three individual parts, and similarly the lengths of each part also we can assume as L1, L2 and L3. And this bar with these specifications, that means the dimensional specification is subjected with an axial pull on both sides of equal value. A force, that is the tensile force, that is the pulling force of same amount, is applied on this bar. So when this force is applied, how to find the total elongation of this bar, that we need to analyze here. So that is can be considered as a elongation, so that is or extension of this entire bar, that we can use the symbol as delta L, and this delta L can be written as the sum of individual extensions going to take place in all these three parts that we can write. That means it can be written as for part 1 as delta 1, that is the extension in the first part, and plus delta 2, that is the extension in the second part, and plus delta L3, that is the extension in the third part. So sum of all these three elongations in these three parts can give the total elongation in the bar or extension in this entire varying cross-sectional bar here. And still again we have to know what is delta L1, delta L2, delta L3 with the specifications given and as well as the pulling force is given. So for that we can use the formula that we already know, that is delta L is equal to PL by AE. This equation is obtained from Hooke's law, that is modulus of elasticity is equal to stress by strain. So from that equation we can get this modified equation, that is PL by AE, and this equation we have to apply individually to these three parts, then we have to make the sum, then we'll be getting the total extension in the bar. So the representation we can give as extension of the bar delta L is equal to, we can write it as P1 L1 by A1 E1. That means in place of delta L1 we can write this one, and plus in place of delta L2 we can write it as P2 L2 by A2 E2 plus P3 L3 by A3 E3. So because of these three parts we have taken the suffix as 1 2 3, but here when you observe here the bar is applied with one single force, that is P only, on both sides it is of same value. So in place of P1 P2 P3 we can write it as P only, so we can write it as P is equal to P1 is equal to P2 is equal to P3. So in place of all these three we can write it as P only. So similarly one more condition we can consider, that is Young's modulus if the bar is of same material. So if all these three individual parts of a single bar is made of a single material, that means of same material, then the Young's modulus of these three parts will be same only. So we can write E is equal to E1 is equal to E2 is equal to E3. That means in place of E1 E2 E3 we can write it as E only because it is of same material. So finally we can write the equation delta L is equal to as PL1 by A1E plus PL2 by A2E plus PL3 by A3. So in all these three terms P by E is common, so we can take P by E as common, then the remaining terms we can write it as L1 by A1 plus L2 by A2 plus L3 by A3. Okay, so with the given information in the problem we can write the total elongation in the bar by using this formula we can write. Okay, that is the total extension in the bar. And next we try to consider a different example which is provided with different amount of the forces are applied on each individual part here. Okay, in the previous case that entire bar is applied with only one single force, but here I'm considering the same bar which is applied with different amount of the forces on each and every part here. So that is P1 I am assuming that is applied on first part, and P2 I am assuming that is applied on third part, and P3 and P4 are both are applied on the second part here. So the different values of the forces that I am applying on this bar, and in this condition how can we find the that is extension that we need to analyze here. Okay, so for analyzing the extension, and again extension in each individual part, we have to know what is the force that is going to act on this individual part. We have to know first. So for that we need to take the free body diagram. So that free body diagram I'm considering for first part, and it is applied with P1 on left side. So P1, so whenever it is applied with P1, this body will try to resist the P1 force. So in opposite direction it can resist the force of equal magnitude, that is of P1 only. So the force acting on the first part is P1 only, and similarly when you come for the second part, and this is the force acting on this part is the combined effect of all the forces. So that combined effect can be written as the resultant force acting on that middle part. That can be written on right side as the sum of these two, because these two are acting in the same direction. So on right side of this part we can consider as P2 plus P3. On left side we can consider it is as P4 minus P1 or P1 minus P4, because these two are acting in opposite direction. So finally we can represent the forces acting on this middle part as P4 minus P1 as a resultant force on left side, and P2 plus P3 resultant force on right side. And here one more thing we have to remember, that in the calculations experimentally, this P4 minus P1 and P2 plus P3 are going to be same values. Okay, that is the that is the required thing. So whenever these two values are different means that problem is wrong. So these two values are going to be same while we are analyzing the resultant force on this particular part. So please try to remember that. And next we go for third part. So on third part here, it is applied with the compressive force P2. So whenever it is applied with the compressive force P2, it will try to again resist the force P2 in the opposite direction. So P2 in opposite direction acts on the other end. So completely it is under compression. So that is a free body diagram for third part. Okay, the simple thing is here, for first part whatever the P1 is there is acting, same P1 we need to consider on both sides for the first part. Similarly whatever the P2 is acting on the third part, we need to consider the same P2 that is going to act on the same part as a compressive only. For the middle part only we need to do some analysis to know the what is the resultant force is going to act on this particular part. Okay, so now we can write individually the extension in part 1, part 2 and part 3. So we go for writing the extension. Delta 1 is equal to, we can write it as P by PL by AE. So in terms of PL by AE we can write it as P1 L1 by A1 E1. That is the extension in the first part. Next in second part, that is the extension, we can write it as either this force or this force we can consider, because these two are going to be same. So P4 minus P1 into L2 divided by A2 E2. Next delta L3 is equal to P2 L3 by A3 E3 we can write. So by taking sum of all these three values, we will be getting the required extension that is going to happen in the entire varying cross sectional bar here. So this is the procedure we can follow to find the extension in the entire varying cross sectional area bar. Next we go for compound bars. So in compound means two different materials are joined together to make a particular part here. So that means one bar which is made of two different materials. So in that condition, how to find the stresses, or what are the conditions we can consider regarding the stresses and strains that we have to analyze. With the help of that we can solve the problems. So first I am considering a compound bar which is of two different materials. These two different colors I have given to know that is made of two different materials. So assume this is one material and this is another material which are made together as a single part, and here I am considering it is constrained or rigidly fixed at a particular end, and now I am applying with one axial force, that is P, which is acting downward direction. So in this condition, what are the in this situation, what are the conditions we can consider which are helpful for finding the stresses induced in this each and every individual part, and as well as the strain induced in the two parts that we can find here. So those condition is, first condition is the load P is shared by the two materials. So whatever the load we are applying on the bar P, this P force is shared by the two materials. If you assume P1, that is the load acting on first material, and P2 is the load that is acting on second material, which are P1, P2 are shared loads from the P here. So that P is equal to, we can write it as P1 plus P2, that is the load acting in one material plus load acting in second material. So like this, the load will be shared by the compound bar. Okay, and this P1 and P2 again we can write from the known equation, that is of stress equation. So in terms of stress, we need to write the equation. So we know already the stress equation, stress is equal to load by area. So load is equal to, we can write stress into area. So P1 is equal to, we can write as sigma 1 into A1. That means stress induced in first part and the area of the first part. Similarly, P2 is equal to, we can write it as sigma 2 into A2. So that is also stress induced in the second part and the area of the second part. So finally, we can write the load acting on the bar is equal to sigma 1 A1 plus sigma 2 A2. So this is the helpful equation which is related to the compound bars here. So with the help of this equation, we can find what is the, whatever the unknown element is there in the compound bar. That is in terms of stresses in one material. Okay, any one of the stresses we can find in one of the materials by knowing stress of one particular material. And next here, the strain produced in the same two bars. The next condition is, we can consider the strain produced is same in two bars. That means whatever the strain that is going to happen in one material, that is equal to the strain produced in the other material. So that equation can be written as E1 is equal to E2. So from Young's modulus of elasticity, the strain is equal to, written as again E. First we try to write the equation, that is of Young's modulus of elasticity, that is sigma by E. So from this equation, the strain E is equal to what we can write? E is equal to, we can write it as sigma by E. So we try to apply this equation to this condition, that is E1 is equal to E2, that is the strain is equal in both the materials of compound bar. So we can write it as, with suffix sigma 1 by E1 is equal to sigma 2 by E2. Okay, this is the condition. So with this condition is also helpful for solving the problems related to the compound bars. So this equation again can be written as sigma 1 by sigma 2 is equal to E1 by E2. That is the ratio of two stresses induced in two different materials of compound bar is equal to the ratio of Young's modulus of elasticity. That means two Young's modulus values of the two materials. So these two conditions, that is P is equal to sigma 1 A1 plus sigma 2 A2 and sigma 1 by E1 is equal to sigma 2 by E2. These two conditions we can consider for solving the problems related to the compound bars. Okay, so this is only the explanation for analyzing the compound bars, and as well as previous we have discussed about bars of varying cross section. So what are the formulas we can consider for solving the problems related to bars of varying cross section and the compound bars that we have discussed here. And if you still have any doubts regarding the problem, so while you are solving problem, if you get any doubt, please feel free to give a comment to my video so that I'll try to clarify your doubts. And here once again, thanks for watching my video, and please don't sorry don't forget to subscribe to my videos, and please share my videos with your friends. And once again, thanks for watching my video. Thank you all.